Okay, Paul here, and today on the bench I have another radio, antique radio. This is a Halton, and the radio's in pretty good shape. It looks like the case is in pretty good shape. It's got some stains and some wear, which is normal for an older case, but no real cracks or breaks that I can see. A little bit of shrinkage on the wood in places, which again is normal for the age. But that's the case. It's in pretty good shape. The dial indicator is in good shape. Needs a little bit of cleaning, which we will do. And clean them as best we can. The knobs seem to be, must be the tuning knob, and the tuning indicator is not moving, it's just jiggling, which means that the cord is slipping. So we'll find that out. Seems like wooden knobs. I'm not sure. Maybe. Yeah, it looks like wooden knobs. And this is the back of the radio. It has its AM antenna. Test code number 7, and then it has a number 60129, which may be the model number or may be the chassis number. I can see a 12SA7 here, so it's probably a standard All-American 5 with a 12SA7, 12SK7, 12SQ7, probably 35W4. And 25L6 or 50L6 or something like that for a power amp. But let's see if we can get any sound out of it. I imagine the filter capacitors in it are short. So let me just a second. Okay, I'll turn my variac on, and we'll bring the voltage up a little. Okay. I'm at just 40 something volts, just enough to see if it's going to draw any current. Right now I'm on 0 amp, so we'll turn it on. 240 milliamps. Of course I do have, and it's dropping. That's pretty good. I do have my current limiting bulb on up there, which is limiting the current. Okay, so we don't have no problem with the voltage there at 40 volts. Let's bring it up to a usable voltage. The light's still out, so we're fine. Let's see what we're drawing on 90 volts. 150 milliamps and 13 watts. Not bad. That should be enough to get it to play. Let's see if we get any sound at all. Well, what do you know? We got sound and we don't have much hum. Again, the indicate channel selector's out. And I don't know if this knob is doing anything. Oh, it's trying to move. Okay, let me go ahead and pull it out of the case and see what we can do with this. But we're off to a good start. We don't have a loud filter capacitor 60 hertz or 120 hertz hum, and that's a good thing. So we'll go ahead and shut it off, drop the power supply off, and I'll take it out of the case and we'll check it out. Okay, and here's the radio out of the case. And it has 2 glass tubes and 3 metal tubes. And it definitely needs to be cleaned. That filter capacitor is full of crud. Has 1 wax capacitor here on the antenna. The screw's a little loose. I did notice when I was taking the screws out of the bottom that it had some paperwork on the bottom. It's got date sold, but it doesn't seem to have the date stamp on it. And I can see that it is a 50L6, 12SK7, and of course 12A7, 12 Q7. Let's see what we got. Here's a 12SQ7. This should be the 50L6 output tube. Nope, 35Z5 rectifier. Which means that they get the output tube here. And yep, 50L6. It's a good amp. And this one should be the 12SK7. Yeah. Tubes are nice and solid in the socket. I like to see that. That's a good thing. Looks like I might have a lot of original tubes too. 12SA7. And that one may be, that's fine. Okay, let's see if we can get something out of it now. We gotta watch this pilot light, make sure that it lights. But we'll try it again. Okay, we'll bring it up to, again, around operating volts. Around 90 is fine. And turn it back on, good, the pilot light's working. The reason that's important is because in many of these radios, the pilot light works with the rectifier tube to be a diode, a fuse system. And if the pilot light don't work, a lot of times the rectifier tube will burn up, the filament will burn up because it was wired that way intentionally. That way the tube acts as a fuse. The tube short, if there's a short, the tube burns out. Tubes were cheap back then. You could just go and buy a replacement after you figured out what the short was from. But now tubes are not as cheap because they don't make them. So we want to make sure we don't burn out tubes. Okay, I'm not getting no sound. Duh. Give me 1 second. Okay, let's try that again. Can't get much sound without the speaker connected. Amazing. And that's with the original caps. That's our local station. So we probably need a dial string because the dial string seems to be bound up a little. And it could be just that it needs to be worked some. I know this is hard to turn, so the capacitor definitely needs to be cleaned. But we got sound. I wish it was off for a song because of the copyright stuff. Tried to get that out of there. Okay. There we go. And not get funding. Coronavirus now blamed for more than 56,000 U.S. deaths. Nearly a million. Okay, that's without an antenna. The disease. Attorney General Bill Barr is telling federal prosecutors to watch for potential coronavirus restrictions that could violate the Constitution. In a letter to authorities, Barr wrote that if a state or local ordinance
ordinance crosses the line into violating civil and constitutional rights, the Justice Department may have an obligation to address that overreach in federal court.
Fox's Rachel Sutherland in Washington. America
I'm trying to hook up my outside rinky-dink antenna. There we go.
Since yesterday, additional Hall County residents have died of complications from COVID-19. The Georgia Department of Public Health says 15 Hall Countyans are among the 1,025 deaths in the
Oscillator's making some noise.
Now updating cases, numbers, and deaths each hour. You can find a link to the reporting website.
But that's just amazing to be playing that good with original capacitors. That's excellent. That means it's a good radio because it hasn't been played for thousands of hours, or those capacitors would not be working that good. But we'll get it playing better. Okay, so let's look at the bottom and see what we got down here. And let me get a light shining in there. Filter capacitor, and it's a dry electrolytic, and it's probably been in there, price tag on it of $2.20. Geez, that's old. But I was about to say, if it isn't original, it was probably added shortly after the radio was made, so apparently it was serviced at one point, because I also see they changed out a capacitor here, which also needs to go because it's a wax capacitor and it's old too. This radio has not seen much service, and when it was serviced was shortly after it was put into service, because almost all of this is original, and it has 5, 6, 7 wax capacitors that I can see. That's about typical. Couple .005, 0.1, couple .1s. Anyway, it's a standard schematic. More power resistor there, 200 and this one's 27K, 2.7K, sorry, resistor, and it's got a couple carbon resistors. There's one there, 2.2 meg. Over here we have a 150 ohm, and there we have a 470 ohm there. So those should be fine, but I'll check them and make sure. We also have a 22K there. So not much in the way of resistors. You got 1, 2, 3, 4, 5 resistors, and 6 resistors, and 7 capacitors. Standard circuit for this tube complement here. So the radio is doing good. Got to get the tuning going. Got to clean it out, obviously. Change that filter capacitor because it is going to die, even though it hasn't died yet. It's weak and it's dry because it's a dry electrolytic, and as the name implies, they dry out really fast. They're dry when they're made, in the sense that they don't use a lot of electrolyte like in the canned ones that stand on the top of the chassis. It's a different electrolyte between the plates, but unfortunately that electrolyte disintegrates in those cardboard cases and just evaporates right on out of the case, and they end up getting really lightweight because everything just evaporates in them. These wax caps, of course, they got to go because they leak DC, and leaking DC is dangerous to the tubes as well as other components like the resistors and stuff. But usually it takes a toll on the tubes, can take a toll on that output transformer and on the IF cans, and you definitely don't want those going bad because they're irreplaceable. So we want to make sure the tubes don't die from too much voltage or too much DC on the grids. Capacitors are supposed to block DC, but they don't when they get old, and they get out of spec. These are all 20% capacitors, and and I'm sure they're well out of 20% tolerance. But we will check them. We'll disconnect one side of one or two and check them and see how bad they are, and then go from there, and you'll get to see it in the video. As far as this string, it looks pretty good. It looks like the string is not dry rotted or anything. I'm thinking most of the problem there is all this dust in this capacitor, and it's affecting it wrapping around here, so around this shaft. So what we got to do there is retension this spring. You can see the spring is totally collapsed, and it should have a little, it should be like that. It should be a little bit of tension on it, but it's so collapsed that the string is now loose. And between the string being loose from stretching over the years and this capacitor being dirty and hard to turn, this wheel just slips. Well, actually the shaft slips. The string won't turn. If I turn it by hand, you see the string's moving fine. And there's nothing wrong with that string. It's just got to be retensioned, and we can do that here. Put enough tension on it, see it wants to go. We get that capacitor cleaned and work this string a little, put a little more tension on this spring, and that'll be fine. But most of what we'll be doing on this radio is preventive maintenance. Fix this and clean it, but other than that, it'll be preventive maintenance. We also got a capacitor here that'll need to be changed. It's another wax capacitor. I change them all because you need to change them all. I've uploaded a video where I had a radio working, and it was working fine, and I was getting ready to change the capacitors, but it was late in the day, so I called it to quits. Come back in the morning, and I plugged the radio in and turned it back on to continue working on it, and it wouldn't play. Wouldn't play at all. Took me hours diagnosing and troubleshooting, trying to figure out why it wouldn't play. I went component by component, and it was when I got to the very last capacitor. I don't even know what made me check it, but I went ahead and checked it, and it was a bypass to ground capacitor, and it was taking the plate voltage off of, the B plus voltage, and grounding it to the chassis. I had 88 volts of B plus voltage the night before, and I figured, well, I got to change the caps. But when it wasn't working, then I was like, well, I got to get it working before I worry about, doing a cap replacement. I didn't know that a capacitor went bad. I assumed it was a resistor because there was no voltage and it was drawing no current. Turned out it was a capacitor. I started on one end of the radio going through all the components, and it was on the opposite end in the back, of course. but that just shows how fast they can go out. I mean, that radio just went out when I shut it off that day, and when I came in the next morning, it wasn't working. And these capacitors will go out. If you're lucky, they'll go out. They'll open up, and it won't do any damage. That one did terrible damage. Instead of opening, it actually shorted to the chassis, which shorted out the B plus to ground, which could have had devastating effects. If it had shorted somewhere else, if it was a different capacitor that shorted and shorted to the wrong place and through B plus where it didn't belong, you know, the high voltage where it didn't belong, it could have burnt up a whole lot of stuff, or burnt up some tubes, or destroyed an IF can, which is a big, big problem because, like I said, these cans are irreplaceable. Finding one that would work is not an easy task, and then it's not original anymore. So we don't want to leave them in there. They're just too dangerous. They're too old. They're out of spec, and we'll verify that as we go with this video. But for now, this is just the introduction on this cool radio. I want to pull the schematic. Not that I need the schematic for this radio, but I want it just because it's a cool radio, and be nice to have the schematic so we can see what it says about tuning the IF and checking the voltages. I kind of know what they should be, but having the documentation that tells you exactly is always nice. So I'm going to work on that, and then we will continue on this radio. Appreciate you watching this introductory video. If you find it informative, please give me a thumbs up and consider subscribing to my channel. This supports me, and I appreciate that support, and helps me and encourages me to keep on making these videos and passing on this knowledge to other people who are learning the trade. So please consider supporting me, and thank you for watching.